Happy Friday, everybody. We're going to start out with this graphic organizer that you guys did on Wednesday or Thursday, but we're going to do the other side of it. So the side that you've done already is the transformations of quadratics. So if you don't have that yet, go to the back bookshelf and find this graphic organizer. We're going to do this side today that says Vertex, Form, and Transformations. The sub can pause right here and allow you some time to get those out, but I'm going to go ahead and jump right in the video. So we have vertex form for a quadratic. A quadratic has the squared term right here. The parent function, I just want to make a note of our parent function again, is when you have no frills, no bells and whistles, and it's just simply y equals x squared is your parent function right there. We know that the a value in front will dilate and reflect your parabola. So I'm going to write dilate, dilation, reflection. We know that the h value will do a horizontal shift, sideways. And I also want you to notice that it's going to go in the opposite direction. Okay, so this little minus h means it would go in the, if you had say -3, you would shift the parabola in the positive direction 3 values. If it said +3, you would shift it in the negative direction 3 values. The k at the very end, that is a vertical shift up and down. Shift up and down. That's an easy one to see. Now, something interesting that we haven't talked about yet, but you're going to see today in 9.1.4 is how this vertex form actually works for absolute value functions as well. So these are absolute value functions. So over here, our vertex is at h comma k, and you're taking the opposite number. So if you see a -3, that'll be a +3. If you have a +5, that'll just be a 5 right there. And we end up having the same situation over here with your absolute value. H. So for absolute value, you end up having a vertex again at h comma k. All these numbers are going to transform your absolute value function the same way they do on the parabola. So let's make a note that your absolute value function is like a v, and the parent function for absolute value, no bells and whistles, is simply y equals the absolute value of x. And you're going to get a little reminder in today's lesson on what absolute value does. In a nutshell, it makes everything inside the bars positive. Okay, oops, there we go. So how do we get a parabola, a function, a quadratic function, into vertex form from standard form? Well, I've given you a really yucky looking problem here. And the first thing you're going to do is we're going to convert this to vertex form, because if you know your vertex, you can just follow the pattern out. Over 1, up 1. Over 2, up 4. Over 3, up 9. So let's get this into vertex form. We're going to start by setting this equal to 0. So set equal Oh, you know what? Don't. Just set it equal to y. So this is a y right here. Y equals negative 2x minus 16x minus 29. Okay? And then, that's step 1. Step 2 is we're going to divide everything by 2. Why? Negative 2. Why are we doing that? Because we have a leading coefficient, and we want to get rid of that leading coefficient. So we're going to divide by negative 2. So I divide this side by negative 2 and that side by negative 2. When I do that, I now have y divided by negative 2 equals, well, negative 2x squared divided by negative 2. Those cancel. I just get x squared. Negative 16 divided by negative 2 turns into a positive 8x. And then over here I have a really yucky decimal. And I'm just going to get that decimal right now so we don't have to worry about it. It's going to be plus 14.5. So on this side we have a fraction. Don't let that stress you out. This is worst case scenario. And now we are going to move our c term over. So move the c term. Move c term. So I'm going to subtract 14.5 from both sides. When I do that, I get something very yucky looking on this side. Y over negative 2 minus 14.5 equals x squared plus 8x. We're now ready to write this as tiles. So if I were to write this as tiles, I would have all this is on that side, but I have x squared. And if I split these guys up, I have 4x here and 4x there, which means that my length and my width are going to be x plus 4. Well, it's not a square yet. I'm missing some tiles. How many am I missing? 4 times 4 is 16, so I need to add 16 tiles. And if I add 16 to that side, I need to add 16 to this side as well. So I'm going to come on over here now. So on this side of the equation, let's clean it up. I have y divided by negative 2, and then I have negative 14.5 plus 16. So that's going to turn into just plus 1.5. That's on that side of the equation. On the other side of the equation, I am going to write this as a perfect square. Length times width, it's going to be x plus 4 squared. So let's make a note on this side over here that we are writing it in perfect square form. If you need the substitute to pause the video, back it up. That's totally fine. You will also be able to find this video on Google Classroom and in our Neo resources. Okay, last step is to get y by itself. Oh, I forgot to write over here that we were completing the square. You might want to do that. Complete the square or add tiles. Okay. Tiles or numbers, okay? So now we want to get y by itself, so we're going to solve for y is our last step. Solve for y, because we wanted to say y equals something. So I'm going to subtract 1.5 from both sides, like that. And I'm left with y divided by negative 2 equals x plus 4 squared minus 1.5. And then y is being divided by a negative 2. So to get it to the other side, I'm going to multiply the entire equation, both sides, by negative 2, like that. That's going to cancel on this side, so now I have y equals negative 2 times all of that. And I'm going to write it all out. Negative 2 times x plus 4 squared minus 1.5. I'm going to do the distributive property here. It's going to go right there and then right there. And so y equals negative 2 times the square, and then 2 of 1.5 is 3, and a negative times a negative is a positive. That is my vertex form. And my vertex, I can see, is going to be at the opposite of what's inside the parentheses, so negative 4, and then the last number, 3. That is probably the worst case scenario that you will ever see for completing the square. You had a leading coefficient that was negative. You had decimals. You had to move that number back over to the other side right here, distributive property. I wanted to make sure you saw worst case scenario so that you felt like you could handle anything. In order to really get comfortable with this, I want you to study all the steps. Talk yourself through. What did we do here? Why? Oh, so we can get this and draw it like that. What did we do here? Why did we do that? Oh, because we need to get y by himself on one side. Okay, that's how you study, is you talk yourself through these things. So down here, we're now going to look at how to graph from vertex form. So if you have something in vertex form, like these two examples, what the heck do you do? Well, we start by graphing the vertex. And our vertex in this situation right here is, I'm going to mark it right here. If we have x minus a negative 1, that will turn it into a plus 1, and then we have our k value at the end over here. So our h value is negative 1, and our k value is negative 3. So I can plot that down on the graph. I can plot negative 1 down 1, 2, 3. Okay. My line of symmetry is the x value from my vertex. That's my line of symmetry. Goes right through the vertex right there. It's right at negative 1. So I know my parabola is going to go there. I can see that because I have a positive a value, it's going to be opening upwards. Okay. I can also see that I have this transformation, the slope, if you want, it's not really the slope, but the dilation is by 2. So right here it says step 2, the a value determines if the parabola opens up or down, and if it's wider or narrower than your parent function. Well, we got the up part. Find the y values by thinking about the parent function. So we're going over 1, up 1, over 2, up 4, over 3, up 9, and then we're going to multiply by the a value for each of those, and we'll use symmetry to then plot the other side. So the transformations, we'll get to that in a moment, but if I were to go over 1, I'm not going to go up 1, I'm going to go 2 times 1 squared. Well, that is 2 times 1 squared is just 2. So I go over 1, up 2. If I go over 2, I'm going to take my a value 2 and go over not 1 squared, but 2 squared. So I go over 2, and now I go up 8. So there's 3, 4, 5, 6, 7, 8. If I were hypothetically to go over 3, then I would take my A value, which is 2, and go up 2 times 3 squared. So the 1 squared, 2 squared, 3 squared comes from your parent function, but we have dilated it by a factor of 2. Okay, so the transformations, let's first use symmetry to plot this out. So I'm going to put that little guy over there, put that little guy over there, and we're just going to feather this out like that. The transformations we have are, you can write translation, you went left 1 and down 3, and then we have it has been compressed or made taller. If you want, you can have dilation by a factor of 2. Let's look at the second example. So we are starting with our vertex, and our vertex here. Again, if you have x minus h, well, that means that 2 is our h value right there, and k is at the end. So our h value is positive 2, take the opposite number there, and our k value is 4, which means that our vertex is going to be at 2, up 1, 2, 3, 4. There's my vertex. My line of symmetry is the x value of my vertex, so that's x equals 2. So I can draw my line of symmetry right down the middle right there. I can see that my leading coefficient is negative, which means this is going to open downwards. So it's going to come this direction like that. Again, we can see that we have translations. We've gone to the right 2, and we've gone up 4, to the right 2 and up 4. We all have a reflection and a dilation. Okay, now we're ready to use our pattern to graph the parabola. So if I go over from the vertex 1, I'm not just going to go down 1, I'm only going to go down a half. So I'm going to go down this half right here. So I go over 1, down a half. And I can do that on the other side, use symmetry. If I go over 2, I'm going to cut that in half. I wouldn't go down 4. I would normally go down 4, right? Go over 2, down 4. But I'm going to cut that in half. So what's half of 4 is only 2. So I go over 2, down 2. Over 2, down 2. And let's do one a little bit farther. Let's go over 4. If I go over 4, I wouldn't just go down 4 squared. I need to cut that in half. So 4 squared is 16. Cut it in half is 8. So if I go over 1, 2, 3, 4, I'm going to go down 8. 1, 2, 3, 4, 5, 6, 7, 8. Right there. And I'm going to reflect that on the other side of the line of symmetry. And there's my parabola. Just like that. So if you can figure out where to upload this to your digital notebooks, if you're in period 1, 2, and 3, go ahead and do that. If not, wait for me and I will explain it to you on Monday. You might want to keep this out for today's lesson, but it might also, you may not feel like it's that relevant because today's lesson is going to be on absolute value. Okay?